Okay, let's look at practice 9. We're going to look at convolutional neural networks and how they work. So as before, we import our libraries here. We've added some libraries to Keras here, including our convolutional neural network. We also have long short-term memory network and max pooling in here. Some of these we won't get till later, but we've got a number of layers to choose from here. First thing we're going to look at is how we actually apply filters to our image here. This image kind of illustrates this. This is showing a 3x3 filter that's applied repeatedly to this image. And this one looks at so we applied in different locations, and we get that we apply, like here we're multiplying the top left corner by 1, and then the next one by 0, and then the next one by -1, and then we're getting this. So you can kind of see as the filter shifts through, we fill up another image. This image is not as big as this one because again we can't go all the way to the edge. Sometimes if we want this image to be as large as this, we buffer the edges of this. We maybe put zeros or something like that around there. So there are ways to make this convoluted image the same size as this, but normal applications, if you don't do anything extra, makes it a little smaller. So we're going to have you try to do this manually with a couple different filters. So here's a spreadsheet. I want you to make a copy of this and then submit that copy in here. And I want you to do some work on this one. So I'm going to make a copy and work on that copy. So here's our original image. It's supposed to be a peace sign, looks kind of like a freaky alien actually, but let's just say it's a image here. And we're going to apply different filters to it. So the first thing we're going to do is apply a 2x2 max filter here. So what that's going to do is we're going to look at 2x2 region here and find the maximum value. So these 4 cells, they're all 255, so the max is again 255. So we're going to put that in since we're in the upper left hand corner of the image here, we're going to put that in the upper left hand corner here. So we applied the filter here for that. So next we're going to shift this over. So we just applied the filter here and we're going to shift it over. I'm going to highlight it as we go. So here's our next spot. We're going to apply that filter. And again, we're going to look at the maximum of these values, and the biggest values are a couple 255. So again, that's going to be 255. So this is a 2x2 filter. We're looking at 2x2 regions here. So we're applying it to this region here. And then we're going to shift it over one more. And how far we shift it over varies. So in this case, we're using what is called a stride of 2. So we originally started the filter here, and then we're going to move over 2. So the next time here. And since it's a 2x2 filter and stride is 2, every time the filter goes into the whole next section of this. So again, now we apply it here. And again, our max, this is what's called a max pooling. So we just look at these 4 values and find the maximum. And here the max is 150. So we put in a 150 here. So as we're going through our filter, we're applying this here. So we'll apply the filter here. And then here. And then again, so I've done that part. Now you'll have to continue on. So here you apply it here. What is the maximum of those 4 values? And so the max would be 150. So you just type in 150 here. The coloring should come automatically when you enter values here. So you've got a 150 here. And again, you might want to apply a filter there. Let me just highlight this. So we've done that one here. If we apply the filter there, the maximum is 255. So we'll put in a 255 there. Similarly, we can shift down, so we can go down. Again, we want to scroll through this whole image, and the stride is 2. So we're going to go over 2 and down 2. So again, we'll look here, and the max here is 255. The max here is 200. When we apply the filter to that location, and then the max here is would be 100. The largest of the cells is 100. There's actually two 100. So again, we've got a 255, a 200, a 100, and you can go on and look at this and what's the maximum of those cells. So you don't have to do this whole image, but just do some more of this image here. Fill in some more of those details to show that show me that you know what's going on here. So that's what's called a max pooling filter. What that does, since our stride is 2, it takes a big image here and reduces its size down in half. So we had a 16 by 16 image, now we'll have an 8 by 8 image. Next, we're going to apply a filter to that image, and this is our kernel filter. This is actually a vertical line detection filter in some ways. And so what we do is we'll look at a 3 by 3 location here on our grid, and we'll apply it here. So I'm going to pull up this calculator here to help us out. So again, this is where we're applying this image here in this location, and this is the filter. So we're going to look at the top left corner and multiply it by this value, and then we're going to go down 1 and go down 1 and 1. So the whole first row here is all multiplied by 1s. So we'll have this each multiplied by 1s. The middle row is all multiplied by 0, so these are all become 0. And then the far right row is all multiplied by -1s. -1, -1. So we add that all up. So that's what we're going to use our calculator to do. So we've got a 255 in the first column, another 255, another 200. The next row is all zeros because, again, each of those numbers gets multiplied by 0. So that's 0 plus 0 plus 0. That doesn't do anything. And then the last row, we're adding them, but they're negative. So this will be a minus 150, minus 100, and minus 150 equals 500. And so then we have another rule here. If the value is greater than 255, 255 is our max, then the value is 255 again. And if the value is less than 0, the value is 0 here. So we just put in a 255 for that location here. And generally you put that in the middle of this location here. That would be that location here would be 255. For that. So at the center of that. So this would be there. Oh, this is actually wrong. And so we are going to, around the edges of this filter, we are just going to buffer it. We're just going to put zeros around the edge here. So there'll just be zeros around the edge. Because, again, we can't really apply our filter to the edge of our image very well. So we'll put zeros around there. So here's our first value we've just filled in here. And again, we can shift this over now. This time our stride is 1, so we're going to move our filter over that far here. So let me change this. Let me unhighlight this. And we're going to switch the filter over just one value here and set it up there. And again, we're going to multiply this by 1. This by 1, this by 1, this by 0, 0, 0, this by -1, this by -1, this by -1, and add those all up, and we'll get 255 here. And your job is then to expand this and then move this over and fill in a couple more of these values here for that. So try to apply this filter to more of this image. And again, you should fill in some of this image by applying the max pooling here. And then the last step is to do one more max pooling layer. This is a max filter with a stride of 2. So again, we'll look at this section, find the max, it's 255. Actually, we would be wanting to do, we would start up in this corner actually and look at that corner. And again, the max is 255. And then we'd move over that, the max of that is going to be 255 too. And we fill in this value of this. So it just shows you how we take a big image, we reduce it in size, we do some filtering, and then we can reduce it in size some more. Okay, so submit. Again, you don't have to do the whole image here, just try to do a little bit more of it to show that, demonstrate you know what's going on. Okay, so that's the first task. And again, share a link in here to your work for that. So now we're going to look at using Kaggle to implement these convolutional neural networks. We're certainly not going to do these by hand. So here's where we're importing the images. This is coming from the Kaggle digit recognition challenge that we've looked at before. So we're reading these in. We're reading in both the training and the submission test image. We're actually taking the training data and breaking up into a training and a test set. And then have a separate submission set here. Well, actually, no, it looks like we just have the training and we're renaming the test, the submission data here. And so again, these are 28 by 28 images, which we've looked at in previous episodes. They're the handwritten digits here. We're doing some simple work on these. We're just normalizing them since, again, they're between 0 and 255. We're dividing each pixel by 255 to normalize it here, and then we're doing some reshaping. And here we're actually doing the train test split to get some training and some testing data for it, and we're doing, it looks like 10% testing, 90% training for that stuff, and setting that up. So here we end up with about 37,000 images, 28 by 28 images for training, and about 4,000 for testing. And that's separate than there's a big pool of submission data, but we don't have the results for that. That's hidden by Kaggle for us. So next we're going to put in some convolutional layers. So if we actually look down here, here's a sample network. We say, like, we had a convolutional layer here. There are going to be 8 filters, so 8 different possible filters, and they're each going to be 3 by 3. And this activation with these filters are almost always leave it at this. These are called rectified linear units, and so that's just standard method here. So leave that generally there. So you can do some different work here and see how this is work. Usually you start we'll make some of these images smaller, and as we make them smaller, we'll add the number of filters as we go. So let's just kind of look graphically at what this might be. So I decided to create a diagram to try to show you how this is working here. So again, what we're doing is we're starting off with a 28 by 28 image. So that's what we kind of see here. It's a 28 by 28 image. And then we're going to apply some filters, 3 by 3 convolutional filters here. And we're going to set up the padding so that we end up with the same 28 by 28 image here. And we're going to do 8 filters. So the computer will select different edge detectors. We'll learn different features here and apply these. And try to create different features here by applying different filters here. And it will try to learn those. And then we're going to apply 8 more filters here. And so we do 8. The first one is 8, and the kernel size is 3 by 3, and the padding is same. So that means that our final image is the same size, so it pads a little bit around. Because remember, sometimes when we apply filters, we can lose a pixel around the edge here. This first layer here, we also have to specify the input shape, and that's our size of our image here. But in our next layer here, the next we're doing 8 filters, and they're 3 by 3 here. And the rest is the same, and we don't have to specify the input on the next one. Then we're going to do a max pooling filter. If you remember, that changes, a 2 by 2 max pooling will change the size of the image. So we'll go from a we start off with the original image, did 8 filters, did this new image. Okay, and so then we're applying this max pool filter, and we'll get a 14 by 14 image, because every 2 by 2 grid will be combined into 1 pixel, so it'll shrink in size both in length and width by 2 by 2. So we'll go from 28 by 28 to 14 by 14. Now, when we apply these layers, when we apply these 8 layers, we actually get 8 different layers, 8 different images here with the different filters applied. So I'm only showing a couple here, but we actually get here. So we might start, I think we're only starting with black and white image, so this is only one filter. Sometimes we start with RGB, we start with 3 colored filters here, but images, but here we just have 1 layer, and then we end up with 8 layers, and then we apply our 8 filters. We have 8 layers again. And now when we do this 14 by, the next max pooling here, we'll again get 8 layers, and then we'll apply 16 filters here and get another image here, and then, oh, I forgot to draw that out, another set of 14 by 14 images here, and then we'll apply our, okay, so we did our convolution 2D, and another convolution 2D, a max pooling, a convolution 2D with 16 filters, and then we flattened that out, and then we did a dense layer with 32, another dense layer here. So that's our structure that we're working with to set this up. And you can, one thing we're doing is printing the summary, so you can kind of see in the summary also. So we start with a 28 by 28 by 1 image, and we end up, after the first filter, we have a 28 by 28 by 8. So there are 8 layers. We apply the next convolution 2D, and we got a 28 by 28 by 8 layers again. And then we do our max pooling, and we're down to 14 by 14 by 8. We apply this convolution with 16 filters 3 by 3, but the padding's the same, so we're going to end up with 14 by 14 ball by 16 images here, or filters here. When we flatten this, we end up with 32 bits. So this is just a standard, like a feed forward network with 32 bits here. And then we feed that, and our final one is our output, and there are 10 different categories. So we're feeding this through with the 10 categories. Now this is a number of parameters we're learning here, and we have to watch this. This is actually a small network. It's 100,000. When we get up to like 16 or more million parameters, then we have to be a little bit more careful, but our RAM up here will easily handle this small layer. And most of the layers are just when we flatten up, because it's a fully connected layer here. Sometimes we might want to make this even smaller, do another max pool to bring this down a little smaller so that we don't have as many connections when we go from there to our flattened layer here. Okay, so your job is to, you can try out this one and then try out some different things. Some things you can do, you can add more convolutional layers. A lot of people will do 3 convolutional layers at a time. Here we're doing 2 here and only 1 here. You can stack these up. Oh, you can add more filters. That was the first thing. So 8 filters or 16. Commonly the idea is that as you shrink your image here, as your image goes down from one size to the other, you should be using more filters, because there's got to be more information held in the filters. So the common thing is that as you decrease the size of your image, you should increase your filters correspondingly. And so that's why at this point we went from 8 to 16 again, but you could try 4 or you could try 16 here, and again you could try growing by different amounts here. You can actually, we're using 3 by 3 filters here, but people have tried different ones. You can use 5 by 5. Some people, there's some arguments for even using 1 by 1 filters. So anything from 1 by 1 to 7 by 7. We'll look in future weeks at some more complicated structures here, but so keep yours relatively simple as we go. You can do more max pooling. Here we did max pooling, so we went from 28 by 28 to 14 by 14. But again, if we did it again, we get down to 7 by 7, which isn't a bad size. You don't want to pool your image down to really small, like 3 by 3 or 1 by 1. Then you lose all your information in your image. So you have to be careful you don't max pool too far down here. Okay. So you can do that. You can try that. And again, we can also add some dropouts here with some different values. And again, you can add them in different places as you go. So those are some things you can do to try out. So try running this training and then try to do some adjustments and see how your training goes here. So we're going to run this. Right now I'm training this with 30 epochs. It should take a while. Each of these runs takes about half a minute, and I'm doing it 30, so this takes about 15 minutes to run. I have some learning rate reduction put in here. You don't have to do that, but again, you can. So again, we're doing some learning rate reduction here, and you can see that's actually kicking in, maybe a little bit too fast. But my accuracy is actually getting up to 100%, which is really good with that layout. So here's my printout of my values here going over, and here's my loss going here. Now it does look like I'm kind of overfitting this because my training accuracy is quite high, but my testing accuracy is not so good. Then you're going to submit this to Kaggle here. So you're going to do a submission to Kaggle, and you're going to report back your best scores as we go for this. And again, try different network configurations. And again, your results for Kaggle will vary depending on how you do this training. And you might be getting 100% here because, again, I've memorized the training data. I'm at 100% of the training data, but my testing data is only 98%. And again, so that's why when I'm submitting it to Kaggle, I'm only getting about 98%. And see if you can get higher than that for these with different configurations. Okay, hope you enjoy this challenge.